Hello everyone and welcome back to my channel. My name is Mary and I'm an illustrator and graphic designer from Canada. This video is part 2 of how to draw and paint birds, and the part of the bird we're moving on to now is the skull. I'm going to tell you about the different parts of the skull, the bones that comprise the skull, and how different adaptations alter the skull shape of birds. You can use this to draw real existing birds, extinct birds, extant birds, or when you're making bird creatures for concept art. I have a few skulls here that I'm going to use to explain some of the bones, and then I will show you a diagram that you can pause and copy into your sketchbook once I'm done explaining some of the big landmarks here. So I've got a big hornbill skull. This is a white-thighed hornbill. And since this skull is so large, it's going to be really easy to see what bones are what, especially in the cranial area. This skull, of course, is very flamboyant. It has an adaptation, the casque here, that most birds aren't going to have. But I think it's quite a beautiful specimen, and it's very surprisingly light, actually. So I'll get the front of the bird out of the way. This is the Hornbills Cask, which is a type of crest, and it's coming here from the lacrimal bone, and it's situated above the top of the bill. So the bill is made out of the premaxilla, which will be the front here, the maxilla sort of behind here, the nasal, and a little bit of the lacrimal here. So the casque is actually hollow. In life it may be filled with marrow or other materials that do not survive the bone cleaning process. But this one here you can see is very hollow and very light, and you can see the structure behind here that gives it that lightness, this sort of lattice structure. Lots of bird bones are built on this premise, which makes them light enough to fly, even with this big, huge nose. So moving on to the lower jaw, we have here the dentary, which is the bottom jaw. Technically, usually, this is multiple bones, but usually it's just referred to as the mandible or the dentary. So mandible, dentary is the lower jaw. There's two sides of it, and you can see where it fuses down the middle. In animals and in people too, this is actually a typical place for jaws to break, but it's also all right because that's an easier place for the jaw to heal too. So we'll put that aside. Moving on to the cranial part of the skull, this part here is obviously the orbit. This is where the eye will go, and birds will also have something called a sclerotic ring, which is a bone inside the eye that helps support it during the extreme pressure changes of flying or diving. This is also seen in flying reptiles and dinosaurs and swimming reptiles like mosasaurs. Moving on, here we have this bone, which is called the Zygomatic Arch. In humans, this is your cheekbone, essentially. This is a place where chewing muscles will attach. This helps open and close the jaw, as do all of these bones in this region here. Here is the quadrate and the quadratojugal. The zygomatic arch here connects to those, and this helps anchor or provide movement to the zygomatic arch from the rest of the skull. There's many different bones that comprise the cranium, and in birds they're quite fused. There are different regions that would be marked out, and I will mark them out on the diagram. But the main thing to know about the back of the skull, we'll turn it over here, is this is where the spinal column enters, and this part here, this sort of bumpy ridge, this is the occipital crest. So that's sort of the back of the bird's skull. This is going to be muscle attachment for neck muscles and biting muscles. And anything on a skull basically that you see has a raised ridge, that's going to be a place for muscle attachment. So there's also a ton of different bones inside and on the bottom of the skull, but if you're drawing something from the outside, I basically want to give you the main landmarks. These are things that you can pull off the top of your head while you're drawing to make a more accurate and believable drawing. So I'm not going to go into all the nitty-gritty of whatever's going on in here, even though it's super cool, because while you're drawing, you're going to be looking for external landmarks like the orbit, the occipital crest, and the bill. Moving on here, we have a Cooper's hawk skull. This is a very different type of bird from the hornbill. You can see it has a sharper beak. This is used for tearing apart prey, pulling it apart. It has a lacrimal bone here, which is very extended. You'll see these extended lacrimal bones very often on birds of prey or birds that are flying at high altitudes and then diving on prey, stuff like that. And you can see the cranium is very smooth. There's very little definition between the different areas of the skull, and that's partly because this is a smaller bird. You can see the zygomatic arch is quite thin, and so is the dentary. So this bird, even though it's small, is going to be very powerful, and it's going to use this pointed beak to its advantage. Despite the tiny, tiny bones, compared to the size of its prey, this bird is still very large. And you can see how big the orbit is compared to the rest of the head. This bird has great eyesight. Going even smaller, way smaller, we have a finch skull. You can see how much the beak takes up of the entire skull. There's a huge beak for crushing seeds, cracking them open. The eye is relatively small compared to the rest of the skull. It's about a third of it, whereas the Cooper's hawk, it feels at about half. So this bird doesn't have the best eyesight, but it's still going to get the job done with a beak like this. So here is the diagram. I think the best way to learn the different bones in a skull or a skeleton is to copy diagrams. So this diagram, of course, is made with information from people who have made other diagrams before me. So continue that process, pause this and copy it if you like. You're gonna learn the names faster that way if you label everything, or if you're drawing birds from life, try to label the landmarks while you're drawing them, or label them when you get home afterwards, just to test your knowledge. This diagram is of a bald eagle skull, which I selected mostly because it's large, it's easy to see the different bones, and it's quite handsome. But there's going to be a wide variety of bill shapes in birds. Birds are a very diverse group of animals, and you can find a lot of information about bill shapes and why they are the shapes that they are all over the internet and in different books. I'll include some links in the description below to some of the references I looked at while I was filming this video, some that I really like, and courses and classes that can help you with animal anatomy. So check below if you want to see those. One other thing to note on the skulls of birds is that they have a bit of motion in the front of their bill. This is called Cranial Kinesis, and there's a few other distinctions among that in birds that basically show like different ways that they can manipulate the front of their bill and which parts of the bill move. But basically, if you can see here on this magpie skull, there's a bit of dried integument here, which this on birds that can perform cranial kinesis or prokinesis, which is one of the types, right here would be where the bill bends up. So this allows them to open their bill without moving their entire head, basically go like this. That makes sense. You can open the bottom bill, but also flex your upper bill up. And this helps birds like finches grab seeds. It also helps birds like parrots. Parrots are really good. You can see a ton of cranial kinesis in parrot skulls. If you just Google it, you'll see tons of examples. It helps them be so nimble and useful with their bills. You can especially see it when parrots yawn. And most animals don't have this sort of range of motion. For example, you can't push your upper palate out. You can't stick your teeth out. That would be crazy. But birds can do that, and it helps them live in their natural environments. This magpie skull here that I'm painting also has a huge cranium. You can see how big the back of the skull is and how round it is, especially in the angle that I'm painting it at. A larger cranium basically means the animal has a larger brain. And brain size is not always equated to intelligence, but for corvids especially, it definitely is. Corvids are incredibly intelligent. Magpies, blue jays, crows, ravens, and other jays, they're so smart, and you can see that reflected in their actual bone structure. So I think that's really interesting. The next video in how to draw and paint birds is going to be about the bird skeleton. There's a ton of bones in the skeleton, ton of tiny bones, and I think what I'll do is basically paint a diagram from scratch and talk through it as we go. I don't have any articulated skeletons in my collection, unfortunately. It would be really nice if I did, but we'll make do with what we have, and I hope to see you in the next video. Have a great week, and thank you so much for watching. Bye!